Okay, in this example, what we're going to try to do is start with two functions, those are the ones that we are given, and start finding the compositions of functions. The first thing they asked us to find looked like fog of x. That's not a good way to read this. What it is I want to take x and plug it into the composition. Well, just remember what that is, right? You're taking x and plugging it in the composition. Now, algebra notation is designed to be read from the inside out. So what I want to do is go to the most inside like that, and wherever I see a g of x, I'm going to put what g of x equals. So this is just going to be f of what g of x equals, like that. Now what am I supposed to do now? Well, what I really need to do now is go back to f and read this in terms of what it does to things inside the parentheses. Again, we start reading from the inside out. What does f do? It adds 3 and then takes square root. So it takes whatever's inside the square, inside the parentheses. That's what was inside the parentheses. Then we add 3, and then we take square root. So that is what f of g of x is. To do g of f of x, which is the next thing we were asked for, this looks like gof of x. That's a terrible way to read it. What we're doing is we're taking x and plugging it into a different composition of functions. This is just g of f of x, like that. Again, algebra notation is written to be read from the inside out. So I go to the most inside thing like that, and instead of f of x, I put what it's equal to. All right, instead of f, I put what it's equal to. It's equal to the square root of x plus 3, like that. Now we're not done. We now want to take the square root of x plus 3 and plug it into g, but in order to do that, I really have to be able to look at g and ask myself, in order, what does g do to things inside of the parentheses? So this is what it does. It multiplies by 2, it adds 7, and it divides into 5. So I need to take what's inside the parentheses, I need to multiply by 2, I need to add 7, and then I divide into 5. And what we get is gof of x. One thing you want to notice, by the way, that order really mattered. F of g of x looks like this. G of f of x looks like this. Very, very, very different, so order matters. Now, there were 2 more things they wanted us to do, so we're going to do those. And you might think they're strange, but we're going to talk about it just for a second. They wanted f of x. You might think that's strange, but there's something about a whole branch of science called dynamical systems where you keep doing the same thing over and over and over. For example, watching a point actually be moved along a river. And this shows up a lot. But we're just going to calculate this one the same way we calculate the others. This is not f of x. This is f of x, like that. We start from the inside. We get f of whatever f was, which is the square root of x plus 3, like that. And then we ask ourselves, what does f do to things inside the parentheses? Well, the very first thing it does is adds 3 and then takes square root. So I take what's inside this guy's parentheses. So I take what's in the parentheses, I add 3, and then I take square root, like that. So that's f of x. You can see I left a whole side over here for g of x, and I'm hoping I have enough room. Over here, I want g of x. Don't read that as GOG, that's terrible, right? This is g of x. Now, how does this work again? Algebraic notation is designed to be written from the inside out. So I go into the inside, and instead of that g of x on the inside, I put what it's equal to. So this outside g is still there. Inside g is equal to 5 over 2x plus 7, like that. Oh boy, what does G do to things again? It takes whatever's inside the parentheses, in order, multiplies by 2, adds 7, divides into 5. So I have to take what's inside the parentheses. Yes. Multiply by 2, add 7, divide into 5. And there is G of x. Oh boy.